All right, we're COMP123 and it's week 4, lesson 4, and it should be part 4, but actually it's part 5. I made a mistake last time. I said it was part 3, but it was actually part 4 when I was talking about the superhero class for assignment number 2. This is part 5. Again, we split off a little bit extra because of some additional discussions we had. Okay, so yesterday we talked about inheritance and how we inherit from our methods and properties from a superclass into a subclass. The superclass in the book is also called a base class, and the subclass is also called a derived class. So you might hear these words, base class and derived class. During the break, I put up another little poll for you guys to kind of do some questions and talk about some of the things we discussed yesterday and today. So you guys can add that to your list of questions for next week's test, right? But let's go over here. So we have a hero class, and this is our hero class that we have here. It's a different hero class than the one from your assignment number 1. There's maybe one property that's the same, health, but the rest are all different, right? So I got a couple things. I said, well, you know what? The hero, he's a good guy or good girl, and the villain, she's bad, right? And I said, I'm going to inherit the villain from the hero. This is good. We can do this. So physically doing this can be done. But my question to you is, conceptually, should it be done? So let me pull the floor here for, should I create this villain class from the hero class? Does it make sense? Think about it. Now, we're not talking about it, can it be done? We're saying from an abstract perspective, when we're trying to take in business rules, okay, these things I'm asking you to do is think about business rules in a real life program. Should it be done? Should we name this class, this derived class or subclass, the villain class? And if we do call it villain, should its superclass or base class be the hero class? Come on, give me. I need some thoughts from the floor here. Let's talk about this. You don't think so? The villain, say that again?
Because then the villain will be capable of doing everything that the hero does.
And can the villain do everything that the hero does? No, right? Not realistically, not in real life. If you really had a hero and a villain, the villain really, he can do, but he won't do. He won't do the stuff that the hero does. That's why he's a villain. So theoretically, yes, we could say that there are similarities between the two, right? But should we inherit from the hero class and make a villain? And probably the answer conceptually should be no, because villain shouldn't come from hero. If I made a superhero, right, it could come from hero, because then I could hear myself say superhero would be almost like a specialization of a type of hero with powers. That's what you're going to be creating next week, right? If I made a supervillain, and if I had a villain-based class, then a supervillain would be like a subclass, specialization of the villain class. But a hero and a villain are quite different, right? They have something called, in real life, I'd call it, if you're reading the comic books or you watch the movies, Marvel movies these days and DC movies, they have moral codes, right? They have a list of moral codes. They have a way they do things that's different, right? So even though physically, like programmatically, we could make it happen, right? The answer is conceptually, and when we're creating business rules, we shouldn't make it happen, right? It doesn't make sense. When a programmer looks at this thing and you see villains and heroes and they're part of the same class, or they're derived, a villain is derived from a hero, that doesn't make any sense. So what we need, if we're going to have similarities between the two classes, is almost like another class. Maybe another class like, like a regular person class, right? A person class or some kind of entity, some kind of class that we can derive both the villain and the hero, right? But that they can take those similarities, right? As an example from this one superclass, if you will, right? But they're different in the way that they don't share methods. Because villains and heroes, the only methods they should share are the ones that everybody has, right? So example, I think if I was going to create a class, and let's do this now, because I asked you yesterday, how do I hide, here's an example of why I'm saying this, okay? So here's my villain class, right? He does bad things, He can do bad things, right? Here's my hero class, right? He does good things. Well, if I inherit from the hero class, there is no way that I can shut down this he does bad things method. It's a public method, and public methods, the way it works when you inherit, when you do inheritance, right? The scope of the public method or the method, it kind of cascades down, just like cascading style sheets do when you do some stuff with web development. Everything cascades down, almost like a domino effect, right? So if it exists in the superclass, it'll exist in the subclass, right? You can't shut it down. You can't say, oh, I don't want you to make this available. If I try and instantiate the subclass, I don't want this one. I want all these methods, but not this one. Can't do that, right? When you inherit from the superclass, you inherit properties and methods, and that whatever their access modifiers tell us, for example, if they're public, right, it's also inherited. Now, there is a thing, and I have to tell you this just from a programming perspective. If I was to override the does good things method, as an example, and I was to try and make it private, which you can try and do. For example, I can make this, if you notice, I have this virtual word here for a second, right? So I was playing with it yesterday to try and explain this nicely, right? I could try and override, right, this method in the villain, right? And we'll talk about overriding methods, right? But if my scope is wide, public, which is everything, right? Public means it's available to members that are inside my class and outside my class into the namespace, right? I cannot narrow the scope to make it private. However, if my hero class, just as a point of fact, just so you guys know for your own knowledge, if the hero class had this as private, the access modifier for does good things was private, so the scope was here. But I overrode it, and in my villain class, I made it public, then it would work. I can always open my scope from an access perspective, but I cannot narrow it again. Just letting you know. So it's just a point of fact, almost like a Trivial Pursuit kind of question. You know, if you ever think about it, if someone ever asks you, say, hey, can you make this public inherited method? Can you make it into a private? The answer is no, because conceptually, when we're inheriting, right, we don't narrow the scope, we widen the scope. That's what we're doing. Okay, so just think about that from an inheritance perspective. We always widen the scope. So this is a problem. I have a problem with my two classes, and I'll show you why. If I go to my program here, and I've got my villain, look, he can do bad things, and he can do good things, and the machine doesn't complain, right? Because I've inherited the does good things method from my hero class, which doesn't make any sense. That should not be allowed. From a business rules perspective, if you think about the concept of a villain, it doesn't make sense, right? We can do it. And I kind of slid it underneath you guys. You guys said, oh yeah, no problem. Sure, yeah, Tom, sounds good. No one said, hey, wait a minute, a villain's not like a hero. We could have had a different conversation. And that's the conversation I want you to take back to your project managers and your, the developers, the developer team. If you want the directors, you should take them back to them and say, I don't really agree with that. I think we should think about naming this class something different if you're going to make a derived class from the hero class, right? Because it doesn't make any sense. The word villain, right, as an example, is not contextual. It's not in the right context that we're using it. And context, when it comes to programming, is very, very important, because if you share your program with somebody else and they're trying to understand what you're doing, they'll be like, but this doesn't make any sense. Sure, I understand what he's doing, or her, I understand what she's doing, but it shouldn't have been done. And once we start rolling, we start programming down the line. Imagine if you're making a game, or tomorrow you're making an app, and you've already done these classes. Going back and fixing it could be a lot of rework. And we're going to do some rework today about this. Okay, let's check this rework out we have to do. So I have to make almost like this superclass, right, that I want to have my villain and my hero kind of inherit from. But it has to be generic enough so that it's almost like some basic traits. Okay, some basic traits. So I'm going to go to the floor and ask some questions, right? I'm going to try and see what you guys think. Can you guys think of a name for a superclass, if you will? A superclass that both the hero and the villain will derive from. I love it. Character is exactly what I was thinking. You stole that right from my mind. Character. Because character is what we're talking about, a character. We don't know in the comic books if it's a villain or hero in the beginning until we see what they do, right? So I like character as to make an, use that as a superclass. So let's make the character. So we're going to go into right-click on our project, and we're going to add a new item. And from a new item, we're going to add in a new class, and we're going to call this the character class. Okay, so here's a character class with a capital C, right? Because that makes sense to me. And I'm going to click Add. So Visual Studio gives us all of the base information here for character. But we know a couple of things that I could kind of do off the cuff, right? Well, first of all, let's add my comment style. So I need to kind of comment and say, this is the constructor. And I'd like you to kind of have some kind of comment style to kind of separate your work. You don't have to do what I do. You can develop your own style, right? But I want you to always indicate where your constructor is for your public and private methods inside of your internal documentation. So when I look at them, if I actually was to look at your work, I go, okay, here's the private method. Okay, here's the constructor, and I can quickly go through. And you could quickly go through. If you look at one of your colleagues' work, you go, okay, here's the constructor. Okay, I see what he's doing here, right? Why? Because we want to be able to communicate with each other as developers, right? We don't want to hide and make our work cryptic, right? Because I'll tell you right now, it's the worst thing in the world when you inherit a piece of code or code base that's completely undocumented. You want to kill the other person or people involved, like literally kill them, right? Because it'll take you time to figure out what these things do, and you'll have to map out the classes and properties and everything else, like literally map them out on a board somewhere to figure out what's going on, how they relate, how they link, all that stuff. Whereas this, the kind of the internal documentation helps. And by the way, this is the kind of a minimalist approach that I'm taking. There are some more documentation that you might see, like for example, what are the input parameters? Name them, and what do they do? You might see that level of documentation. I won't burden you with that right now. Maybe we'll get there by the end, but right now all I care about is just some basics. So here's my constructor, but this isn't where it's going to go because my constructor's not here, right? My constructor's inside my class. And I have to call it the same thing. So it has to be a public constructor, right, which is called character, the same name as my class, right? Right now it's going to be the empty constructor just as we start building. I'm going to plop in this comment here that says constructor. So that's the first thing. All right, this is cool. I know that I'm going to take in this constructor, and when I go back to hero, I know that all this stuff here, health, smarts, and gender, are definitely going to be pieces of the superclass that we're creating, right? So I'm going to take these three. Bravery, this is another one. Does a villain have bravery typically? And the answer is probably not. It's not part of his moral code. He might do some things that people might consider bravery, but most villains in the storybooks, at the end of the day, they're cowards, right? So I'm just saying, right? Now, you might argue with me and you might say, well, no, that's not true. They might say that. But at the end of the day, if you think about the classic heroes are brave, and villains use their minions, right? They use their minions to fight the battles for them, right? And to attack the hero, to wear him down until he's weak enough where the villain can come and chop his head off, right? Put him in a death trap, right? All that kind of stuff. Trick the hero. They're the trickster, right? That kind of architect. But they're not necessarily brave. So I wouldn't kind of inherit this one into my general class. So I would take all these three things. I'm not going to cut them for now. I'm going to copy them. And I'm going to put them inside my character class as private properties. And they're going to go, of course, before my constructor, right? Because it makes sense. Now, hear me out here. If I make these private properties, right, and we're going to talk about a couple of keywords we haven't used yet. Here are my private properties. Will they be available to me to manipulate in my hero class? If you know about inheritance, the answer is no, they're not going to be. Private properties, and that's the access modifier we're going to talk about today, private and protected, are only available inside the class itself. So within the character class, my private properties are available. If I want to make my properties available to the subclass, I have to use the keyword protected. So now it's available to my private, my character class, and any class that derives from it. So that means I got to change this keyword to protect it. Okay, so I can't use the private keyword if I want to manipulate my smarts, my gender, and my health. I can't do that, right? So these are kind of basics, right? So I need to, this is my character superclass we're talking about here. So this is good. Here's another one. I have these things here, right? When I do this as they're incoming here in my hero constructor, right? As an example, I think I'd like to do this in my superclass, right? I'd like to take these into my superclass, because when I call, it doesn't matter whether you're making a hero or a villain, you still need to have health, smarts, and gender. That's just something all of them need. So I think these things make sense for my constructor signature to include. I need to do this. And I probably need to, if you notice, it's almost the exact same thing so far, because I need to do all this right now. Because I need to do this, I'm just going to go back, almost within my, the same constructor. It's almost identical right now to the hero class. I think this is where I'm going to stop, though. So this, as far as I go when it comes to the stuff that I want my character class, my character superclass, and I'm going to make some comments here. So I'm going to make a character, because we're going to change this character superclass for now. I'm going to make my character superclass, but it has these things, right? And these are protected. These are protected. I'm using protected so I can have access to them in the hero and villain classes, right? And now instead of inheriting from there's no inheritance for the hero class, I'm going to inherit from the character class. So I'm going to put an inheritance symbol here. So again, colon, and as long as it's within the same namespace, I should be able to inherit from it. So I'm going to put in character. I'll start typing, right, and there it is. So I do my character. Well, because I do that, you see I get an error here in my hero class because I need to call the base class, the base constructor. And I can do that by calling base and then sending in health, smarts, and gender. Right? I need to be able to do that. I don't need to do this here because I've already done it. Right? I don't need to do this anymore. Okay? That doesn't make any sense. So right now my constructor is empty. Right? I just need to take in health, smarts, and gender into my hero class. And I don't need to create these as properties because they're part of my character superclass. All right? So now if you notice my hero subclass, right? And I'll put this in there. Hero subclass of character superclass. I'm putting it in there so you guys see what it is. You can include this or exclude this. You need to put you should put some kind of description about what the hero class is and so on. And I would probably put it in here in different ways. Okay, so here's my hero class. Here's my private methods, my private properties, my constructor, and my public methods. That all stays the same. Well, this is good. Now let's fix the villain class. Because the villain class originally took from the hero, but that doesn't make any sense. We're going to go and change this to character, right? Because that makes more sense. And now the same kind of thing, string name, health, smarts, and gender. If you notice, we have a name that's a little bit different for the villain. Our hero is nameless. He's a nameless hero, right? If I wanted to be fair, we probably would have something else in here, right? Like for example, you know, I could change this name property to be something that's part of the hero class, the character class, because it makes sense that all heroes and villains have a name. Conceptually, right, that makes sense. So I probably would take this away from here. That's another thing that I probably would take away. I'm just going to copy here and put it into the character class under a protected access modifier, not private. Protected, again, gives access, right, to the name. So that's something that now the hero and the villain share, right? Because I made, in one fell swoop, I've kind of added it to both classes. But now I got to modify my hero class again because if you notice, I don't have a name that's incoming. So eventually when I save everything, I'm just going to save it all, right? My constructor is incomplete in this particular case because I'm not taking in the name of the character here, right? So I probably want to do it here. I want to kind of do something like this: string name, and then of course here in health, I want to go name before health. I want to do that. This is cool, but the reason why this is not good for my base class, if I go back to my character, I don't actually listen for it. So I should do that here as well. String name, so I want to listen for that as well. And probably I want to assign it somewhere, like up here. So this dot name is equal to name. So I don't have to do that within my villain class. So that's a couple of things I made changes to. My villain class now, if you notice, I need to pass in the name as well. And now my constructor it doesn't do anything. It just passes in these things, right? Okay, cool. I don't need this anymore because this private property should be gone. We can add another private property though. Let's add something else that makes sense for the villain to have. So the hero has bravery. It's a Boolean value, true or false. Some heroes are brave. Some heroes aren't so brave. Most heroes are, but some heroes aren't, right? So brave. But maybe something that's part of the villain that that they want. And I'm going to put in a private property called, and it's going to be a Boolean property again, just to make it almost same as a hero but different. And we're going to call it greed, right? So greed, and we'll make this the default value of true. So most villains are greedy, we'll say. Greed, right? Now we never use bravery right now. Bravery and greed, right? We might be able to, right now, because we haven't used it, we can probably change this to courage. Why not? Courage and greed, because that makes sense a little bit better than bravery. Just from a tense perspective, it's the same word kind of, but a little bit different. So again, we have a couple of, this is almost like our moral codes, isn't it? Right? Because here's a hero. We have a private method, a private property called courage, another private property called greed. They have two different properties. Maybe we made some kind of console.writeLine here that kind of displays, the name of the villain as an example. And maybe this is where we would do, because I want to do this, right? A shared property that would be available to both the hero and the villain, right? To kind of display their name, their health, their smarts, and their gender, right? Back to you, right? So that what we do here in the character superclass, right? And when we create our first we'll make a private method, and I'll talk about this in a second. Private methods. Why would I make this a private method, right? Well, I could make it private, or I could make it protected. If I made it private, that means I could only execute it from my superclass. If I made it protected, then I could execute it from within my my subclass. So maybe I'd want to make this a protected method, right? Protected methods. I want to create a new one. It's going to be, the access modifier is going to be protected, and of course it's not going to return anything. And we're going to just say we'll make a show method, right? And the show method, I'm just going to scroll up here so you guys can see. There we go. The show method is going to show the name, health, smarts, and gender. We're just going to do that. So let's just, so we'll do a bunch of console dot write lines for now, right? And again, this is at the hero level, or the character level, right? In the hierarchy, this is the top level, right? If you think about a chain, okay? So I'm going to start writing. So, so let's say name, almost like a profile, right? And maybe we'll call it that, show profile, show, just to make it more a little bit more interesting than just show. And the name we'll do some string interpolation here, and the name of the hero will be this, or the villain will be this dot name. And just because I'm lazy, I'm just going to copy and paste this a bunch of times. Now there's different ways to do this, of course. Health. And smarts. By the way, once I finish this, I'll update it to GitHub here, so you'll have everything I have. Gender, right? So name, health, smarts, gender, maybe some kind of lines to give us a little bit of separation. Right? So we'll kind of add another little line here. I'll get rid of this and make some separation, almost like above and below, just like with these little pluses that I like to use. Again, you can use whatever symbols you like, something that makes sense to you, right? Or a combination of symbols. We're doing console applications here, so we can't get so funky, but you know, at least we can make it somehow interesting, right? Again, even for your code for the hero class, maybe you want to do a little separation for your output, right? To make it easy for you to read. Sometimes more spaces, separated so it looks nicer, right? Because sometimes we do an output and it's just a black console with a bunch of output. We don't know what it is. So name your output a little bit. So there's my show profile, right? Now I haven't called my show profile, right, as an example, and there's a couple things I can do. I can call it here if I want to, but just to show that we can do it, right? To show that we can do it, let's go into our hero class and our villain class and go this dot show profile. Even though it's not here, we can see that the method is available to us, right, inside our hero class. And if I write it again, this dot show profile, it's available to me in code kinting, right? Because even though it's not here, the show profile method, I still can call it because it's part of my superclass. I inherit methods, even though they're not listed here in my hero class. My show profile, because I'm inheriting from the character class, I'm able to use this inherited method, which is protected. This protected method is there. Now, if I change the access modifier, let's do that just so I can demonstrate this for you. From a demonstration purposes perspective, if I change this access modifier, to private, okay, just to show you what it looks like. And if I go back to the hero class, right, I get a squiggly line. And the squiggly line, if I look and kind of go over it, says options to generate a method stub. I can do that. But what it says is inaccessible due to its protection level. So if I don't make it protected, I cannot call it or invoke it from within the subclass. So protected is the way, that keyword is a way for us to invoke a property or method of the superclass from within its subclass or derived class. Okay? The derived class, subclass, child class, they all mean the same thing. Parent class, superclass, base class, that's all means the same thing too, right? I'm using the same words over and over again so you get it, right? All right, so I got to fix this, and the way to fix it is, of course, I'm going to go back to the character class and change this access modifier level to protected. Protected. Need to do that. Okay, this is cool. So I've got I got this thing going now. I got to fix my program now because this is all wrong, the way I'm calling stuff. I definitely can't do this, my hero and my villain. And my villain or my hero, I got to say, kind of, I put a name to it, and let's call her, you know, Bravia. I'm just coming up with it, okay? It's not a cool name, but Bravia, you know, is the hero, and Spider Girl, you can think of a spider, is the villain, right? And I think Spider Girl's going to win because she's got better abilities, 9 smarts and 9 health. She can outsmart my hero right now. But if you notice, my villain now, because I don't have access to does good things. I can't do good things with my villain anymore. It's not available like it used to be when I inherited from the hero, which didn't make any sense, right? So now I have this character class I'm inheriting from, right? But when I'm inheriting from the character class, right, I only inherit pieces of the character class that I need. Wait a minute. If I create a class, right, shouldn't I also be able to instantiate it? And if I'm not instantiating the class, now it goes back to another concept of, when we talk about polymorphism. So again, we talked about inheritance being we inherit stuff from the superclass, right? But now we're thinking about it, and we're like, hey, hold on a second. I'm never going to ever want to kind of create a character because character doesn't make any sense from this context. How would I make a character that doesn't do good things or bad things? There's just a blank slate, right? I mean, if we made it a person, so a regular person, like normal human, as opposed to hero and villain, yes, then maybe they derive from a normal human, but maybe they didn't, right? So, I don't know if it makes sense we could do it, but again, the question is, should we do it? Should we do it? Okay. So, but this doesn't make any sense. So again, I use my hero and my villain. I want to do this, and yet I'm just going to go to Team Explorer, what I'm talking, and kind of add this in. So added the character superclass and changed, I'm going to make a longer one, change the subclasses. Right. So I save this, and I go back home, and I go unsync commits, and I sync. Now you've got your latest version of lesson 4 part 2, which is what it's called, lesson 4 part 2 on GitHub, which is right here. So now if you notice, my GitHub also includes my character class. Here's my hero, here's my villain. Hey, where's my character class? Let me take a look. And I just want to make sure that it's not, somehow I didn't mess up. Maybe it's excluded. I got to figure that out. I may have pushed something that was excluded, and that's why you're not seeing it there. Because it should be seen. You should be able to see my character class, which is a bad thing. And I was too quick on the draw there. Make sure. Yeah, it doesn't look like it's there, baby. And if I was just to be curious and look inside my hero class, my hero class does pull from the character class, but I don't see my character class as a class that I'm sending up. So then, if I make a change to my character class by adding a little comment or something like that, like for example, lock. Gender of the character, just as a silly comment. And if I go back to home and I go back to changes and I see my included changes as my character that I'm going to add, which I didn't have before, I should be able to say added character class and commit. And if I do that and go back home and I go to unsync commits, I should be able to sync up my objects now. And I don't know why I didn't have that before, but hey, you know what? Things happen. And this is where you have to check your, make sure you don't exclude anything. And I probably did exclude it by accident. So to make sure you guys have it up there. Yay. Good. Now you have it. That would be bad. You didn't have the character class. You're trying to inherit a class that we don't have, right? Online. Okay. So I've got the character class, and I've got the hero class and the villain class. But really, my thoughts are, I probably will never, ever want to instantiate an object of the character class. This comes down to the idea of what we call abstract classes. We create a design for the class, but only for inheritance purposes, and not for actually creating an object. Let's talk about that from a PowerPoint perspective. Let's look at this a little bit. So we covered creating classes, extending the classes, and we covered the protected modifier, and the protected data field or method, or whatever you want to call it. Now they call it fields instead of properties in the book. You might see that as well. Instance variables in other books. Properties is what I'm calling them, but they all mean the same thing. Methods are the same, pretty much across. And the only way you could use assign a value to a data field or property or a method that comes from the superclass is to use the protected keyword. Okay, we need to use that. But only when we need to make modifications. For example, maybe we never want to have access directly to modifying our superclass's properties, and therefore we'd make them private. Maybe the only way we'd want to make them available is through some kind of getter or setter, even from our derived class or subclass. And therefore we would make them private or with a public getter or setter. And here's an example of just that. So here's our employee number, employee number is a public number, right? Empnum, and if you notice, empnum is capital E. That's the public piece, right? That's available to all employees. But empnum with a lowercase e, is private, and we assign the private value, the private property for empnum, through our getter or our setter. Here's our setter, here's our getter. We can only get and set the value through this getter and setter access method. That's the only way we can do it. If we try doing it any other way, right, again, this is kind of the established methodology. When we have a property, we'll want to break it up into getters and setters. I'm not using them right now with you, just to keep it simple, but this is definitely a way you're going to see being used almost as a way of accessing properties and methods. So we kind of keep our data hiding, that data hiding piece of object-oriented programming in place. Okay, let me just go forward, for example. So here's protected. And then we talked about overriding for a second, right? So this is where we get into this idea of polymorphism. So inheritance is where we grab or kind of carry forward in a domino-like effect, a cascade of properties and methods from our superclass, right? But again, there might be sometimes we want to modify the methods that come into our into our base class or our derived class from our superclass. We might modify, I'll say it another way, our methods that come into the subclass from our superclass. Same thing, I just said, just two different ways with two different words. So it says a derived class has two things it can do: override and hide methods and data from the base class. Override and hide, right? So that might mean if I want to, maybe I have a method like I do right now called show profile, right? But maybe the show profile for the villain, I want to modify it. And I want to make it slightly different than the show profile for the hero, right? I could do that. I could take the generic show profile class method that comes from my superclass and override it and rewrite it. Let's take a look at how that's done. I need to use a couple of new keywords. One of them has got to be this virtual keyword. So and before the data type, so and after the access modifier, I need to put this virtual keyword in play. Well, here's a challenge. If I was going to use this virtual keyword and I want to override my method, it cannot be something that's, I believe, private or protected. It has to be public. So there's some issues with overriding. If you notice, all these examples use a public property, right? Where I'm setting the value of credits, small lowercase credits, with my uppercase credits setter, right? And I'm going to override the setter so it does something different. It sets my tuition to 0, maybe whereas before the setter was a little different, right? So here's my credits, and my tuition before was credits times rate, and now I'm overriding that property in the subclass, because my subclass, this scholarship student, is a subclass in this particular example of the student superclass, and I'm taking in a new property, right, or the same property, but I'm overriding it with the override keyword and changing what my set method, access method specifier in here, and I'm making the tuition 0 because this guy's got a scholarship. So it makes sense from a business rules perspective that he wouldn't need to have his tuition equal to his credits times his rate. We don't need to do that. There wouldn't be a tuition because he's got a scholarship. Now, there's other ways of thinking about that, conceptualizing how that is. But the idea is here that we're taking the original property credits and modifying it with this override. Is that confusing to anyone? Right? Might be, right? Because you're seeing it for the first time. So, again, think about us modifying, or we're taking this virtual, we're using the word virtual. That's kind of a bad word, actually. It's not a very good good way of describing it. But basically, it's like saying this. Excuse me. The only way we can use the override keyword if we use the virtual keyword. So if I want to override a property or a method, I need to use the virtual keyword. That's one of them you can use inside of my my superclass. I have to almost like tag it. I'm saying, hey, these are the ones that I want to be able to override. Right? I don't have to override them. Right? I don't need to override them. I may override them if I want to. Right? With the virtual keyword. And then in my subclass, if I want to override it, I use the override keyword. So two keywords, the sender and the receiver. The sender has got to have the virtual keyword. Receiver has got to have the override keyword. Because I'm using virtual, I have a choice of either overriding it or not. Right? There is another word that I can use, abstract, which we're going to talk about in a second, where I don't have a choice. I have to override it. Okay? So there's two possibilities. I may override, I must override, right? Two possibilities. And I must override means I have to override it regardless. If I don't override it, when I declare the subclass, it'll give me an error. In this particular case, because I'm using virtual, I may override it, which means if I don't override it, it was not going to complain. Okay? And the only reason why I want to override anything or change what's coming inbound from the superclass is when I want to further specialize my method or my property to make it more contextual or add functionality that my superclass doesn't have, right? Inside the method. So I want to create a new method, right? Because I could create a new method. Like the old way before abstract classes and everything else, when object-oriented programming was kind of rolling out, we didn't have abstract classes. That idea was never there, right? And we just created different, more and more methods. So a method that has, tuition at 0, like, something like scholarship method, right? And it was something else, right? And we had a bunch of other methods. Then we said, well, hold on. Couldn't we make it so that, this is how it was kind of evolved, couldn't we make it so that this, the properties of methods could change? And this is where this whole idea of polymorphism came into play. Polymorphism says I can take, and morphism comes from the Greek word morphe, which means to change or shape, right? And poly means many, right? So many shapes, polymorphism, polymorphy, right? That's where it comes from in Greek. I'm telling you because I'm a Greek guy, right? And so these two words, poly and morphism, means many shapes. I can take the shape of the existing class and I can modify it. I can reshape a bit of the method or the property so that it suits or fits within the concept of my subclass. Now we're talking really high abstract level thinking here. So if you're not going to catch it right away, right, it's okay because this is the first time you're seeing this kind of stuff. And it might take for some of you a little bit of extra time to kind of wrap it around your mind around it a little bit and chew it and digest it a little bit. It takes some time. And the reason for that is because we don't think that way in real life, right? We have a lot of abstract thinking already, but it's part of our being. Like an abstract thing for us is the names of each thing that we see. That's abstract thinking, right? We know what a computer is because we put a label to it in our mind. A computer in our mind. If I say computer, the word computer is loaded with meaning, right? Or if I look at a person, I say person, right? Person. That's loaded with meaning. Person means a lot of things to me. It might be slightly different things to me than to you, right? So there's some abstract thinking we're already doing. It's happening automatically for us as we're in real life, right? But now we're trying to do it in the programming level, at the coding level. We're trying to design a way for the computer to interact or to perform based on this level of abstract thinking that messes students up. Because they think about it and they go, okay, I understand classes, but why? Why would I want to override a method? I don't understand. Why would I just create more methods, new methods? Well, because we want to make it more efficient, and that's why we're doing it. Okay, so let's continue on. Let's talk about this. So we use the base keyword, again, to access a parent class method. We could do that too. Again, see this form? Just because we can do it doesn't mean we should do it. Why would I try and access a base class method in this way? When I know that when I inherit the getGreetings method, now this is a way if I wanted to create my own, if you notice, I'm using the new keyword here, ho ho ho. And this is something new that you haven't seen before too. By the way, I will not test you on this piece. Okay, why? It's an advanced piece. I would say this is like advanced C#. Okay, if I was going to talk about it, we'll talk about polymorphism, right, a little bit. And we'll talk about some pieces of polymorphism. but there's a piece of it that you need to know, which is the hiding piece. This is where you hide information. I'll show it to you, but you don't have to remember it because it's advanced. Okay? I'm just telling you right now. So here's a method, but I'm using the new keyword. If I use the new keyword in a method that's already been tagged for virtual with the virtual keyword, I have two options, right? I can use the override keyword in the receiving method, or I can use the new keyword. Those are two options. If I use the override keyword, I can rewrite my method, my original method, and add things to it, method or property, right? If I use the new keyword, I wipe away the original method, hide it, right, as if it never existed, and then completely write my own, right? So there's two different ways of doing this thing. And then, look, if you notice, without using my original method, right? Without using my original method, I'm going to call my base method, just like if I was creating my own, if I'm calling a constructor. So here's the original method signature, base.getGreetings, right? Base.getGreetings is the original method signature, right? I'm calling it within my new method that I'm making here, and I'm rewriting it to do completely different things. This has some use because if you notice, my getGreetings method that came from my superclass has an output. If I go back, I don't know if it shows my getGreetings method. It does not here, but in the book it'll show it. My getGreetings method from my original class, right? Before I inherit it into this commission employee class, for my employee class, the getGreetings method returns a string. So here I'm kind of absorbing it into this greeting string, and I'm creating a new greeting that says work on commission, right? Which doesn't exist for a non-commissioned employee, right? The reason why this is confusing is you would say, well, isn't it better for me just to override my original method? And the answer for me would be yes. It makes it more sense. You'll see more overriding than hiding. This is almost something that we don't see this as often. This is an uncommon way of doing things. But if you ever see this base get greetings, when I use base anything, I'm accessing the parent superclass or the parent class. I'm accessing methods and properties from there. I could do that with the base keyword, but I don't want to. Just because I can doesn't mean I should. I'm going to say this over and over again. And this is one of these best practices I will ask you to take away and say, nah, there's better ways of doing it. Just like we talked in the first class we were together. We talked about the ref keyword. Should I use a reference? Should I pass things by reference? Can you? Yes. Should you? No. Doesn't make sense, right? From an object-oriented programming perspective. Same thing here. I'm not so sure I would recommend this for beginners, right? Because this is a little bit abstract and doesn't make any sense. They don't know the difference. That you can't tell the difference between using this and overriding. And I would say stay with the overriding idea. Override the method, the one that you tag as virtual or abstract. So I'm just going to keep going here so we get to the next piece. I'm not going to talk about conversions or implicit conversions because I'd like you to think about things that you explicitly convert things. I don't like you to think about things. I don't want you to let the computer ever do things for you. I told you before. I would rather you do things explicitly rather than implicitly at any time, ever. Which means I'd rather you define what the conversion is going to be. If you're going to convert one data type to another, convert it. Don't let the program or method convert for you because you don't know what the result is going to be ever. Right? You can't guarantee what the result is going to be. You'll get a concatenated string result or a concatenated cutoff integer result or something like that you won't want. So if you're going to do a conversion, convert it yourself. I'm not going to cover it. I'm not going to test you on it to do implicit conversions. It makes no sense to me as a developer. I would never do it. Let's pause here for a break. And while I pause here, I'm going to put together some questions. You guys take a 5-minute breather, refresh yourselves, and we'll come back in 5 or 10 and continue.